Hello, welcome. This is the CSDMS Spring Webinar Series. My name is Mark. I'm a research software engineer at CSDMS. It's my shirt. All right, so today's webinar is the first of 2025. It's titled Docker, or What to Do When Software Has Betrayed You. Our presenter is Daniel Shapero from the University of Washington. Daniel's a research scientist at the Polar Science Center in the Applied Physics Lab of the University of Washington. He got his PhD in applied math from UW in 2017. For his research, he works on numerical methods for simulating glacier flow and on how to assimilate remote sensing data into ice flow models. All of this work goes into an open source Python package called IcePack, which is cool. I'm really happy that Daniel's here today. Daniel's given other webinars that I've watched, and I've really enjoyed them, and I've learned from them. So I'm looking forward to learning today as well. All right, so Daniel, the floor, or at least the Zoom feed, is yours.
Okay, cool. Yeah, thanks for having me. So I'm going to talk today about a tool called Docker, and this came up because I'm going to give a clinic at the CSDMS meeting in May, and of course, I love to make these participatory, but I also rely on certain software that can be hard to install. So I was emailing back and forth with Greg and Lynn and suggesting, well, I could offer to people that there's a Docker image if they're familiar with that. And they said that some people are and some people aren't. So I figured this would be just a good opportunity for me to give another little talk about how to use Docker, because it can really save your bacon. So often for a talk like this, if someone is talking about a software tool, they're coming from the standpoint of, wow, look at this amazing new thing that I love and that makes me so much more productive, and it's awesome and I love it. This is more like, if everything else has gone totally awry, this can save you. Look, it's annoying, I'll be blunt, but it's harm reduction. And part of the reason that these tools are necessary is because we're inheriting all of this legacy of the fact that they made the C programming language long before they thought of how they were going to make a build system for it. And so installing any compiled software from source is always a bit of a mess. And so we come up with these Jabberwockian solutions for it. And this is another one of them, but it's really saved me many times. I wish these sorts of things weren't necessary. Every time I use it, I sort of think to myself, every day we fall further from God's grace, but we can fall a little slower, and this is a good way to do it. So, so what is Docker? What does it do? There have been a lot of tools over the years that their general purpose is to let your operating system pretend like it is a different operating system for the purpose of running some software that it wasn't really designed to do. So the general buzzword for this is called virtualization, which is a term you may have heard, and it lets your machine, which is referred to as the host, pretend to be another machine that is called the guest or the virtual machine. And so just some examples through the past is, at one point, Apple switched from using CPUs that ran on the PowerPC architecture to the Intel architecture. But the problem was they had all this code that was written for PowerPC, and they didn't want to chuck it all in the garbage. So what they did is they wrote an emulator for all of the PowerPC code so that your fancy new Intel Mac could pretend like it was a PowerPC Mac. And the thing that probably killed off the company that makes PowerPC was that the emulator running on Intel was faster than PowerPC natively. So they didn't stay in business much longer after that. And this has been used for a lot of things over the years, and the tools have gotten better and better for it. So I used, sort of early on in my PhD, a software package called Elmer Ice. That was a finite element modeling package for glacier flow. And the first workshop that I attended for it, the guy who hosted it, Olivier Gagliardini, just gave around a bunch of DVDs that had a VirtualBox image that contained an Ubuntu system with Elmer pre-installed on it, and we could run that system virtually on our own machines without having to install Elmer for ourselves, because that was more than we wanted to deal with. So what has gotten so much better about these lately is that Docker runs almost as fast as it is natively on your system. So I mentioned there's the emulation thing that people used to do. Well, now, because of some magic that I don't really understand in the Linux kernel, that emulation is no longer necessary, and it's basically running native code just with different permissions. And this stuff gets used all over the place in web development and the software industry generally. One of the things that I think is, well, it's very useful for us, but it's useful for people who do scientific software engineering for different reasons than it is for people who do web development. So for us, if you do anything in scientific software, and especially with Earth system type things, you're going to run into some really weird old legacy Fortran code at some point. And this is a really fantastic tool for dealing with that sort of thing. But what it means is that a lot of the information that you find on the internet about it is going to be not always relevant to the ways that we want to use it. So that's just kind of a thing to keep a heads up about. So one of the helpful analogy when you're thinking about this is if you've ever had to SSH into a remote server. Someone has some machine off somewhere that's hopefully more powerful than your laptop. And if they set up an account and give you a password for it, then you can run code on it. A useful way of thinking about containers and virtual machines and such like is as if you had another server that you could SSH into to run code, but that server was actually located on your computer. And the purpose of this is isolation and all sorts of things like that. So if any of you don't have Docker already installed and you want to follow along, this would probably be a good point to install it. And I can tell you a couple things about what all of that looks like. And I just thought I would get started now for the real stuff. So I'm going to, the rest of the talk is basically two parts. The first is I'm going to show you how to use a Docker image that has already been prepared. And the Docker image is like a blueprint for one of these virtual machines that specifies what operating system it's built off of, what software is already installed on it, and other things. And a container is one of these running virtual machine instances that you can open up a command line and type code into. So the first part of this is going to be how do we use a Docker image that's already been prepared, assuming that some expert has already made one for you and uploaded it to the internet. And the second part is going to be how do you make a Docker image yourself. So the first, let's see. The first and most important thing is where do you get Docker images from? There is a website called Docker Hub where people can upload them. And just to give you an example, I taught a class in the spring of last year, and let's see, what does it show when I actually go to it? Yeah, okay. And I'll talk about this later. So I had some instructions for my students that I put on a Git repository, and I can share those instructions because they might be useful. But if you go to Docker Hub, and probably if you search for UW ESS 524, this is public, then you'll be able to find the Docker image that I created. And the command to get Docker images is in a terminal. If anyone is following along and you just install Docker, it's very likely that you'll have to run it with super user privileges. And if you want to see how to avoid needing that, I can tell you in a moment. But the first command you're going to want to run is Docker images. And that shows you which images you already have fetched. See it bigger. So I have one that is an image containing a software package called Firedrake that I like using for finite element modeling related stuff. And so we can see when it was created, how big it is. Just as a warning, these are often quite large. And another Docker image that contains the code for a software package called Reveal MD that I like using for presentations sometime. Mark gave me some effusive thanks because I showed this to him and he really likes it too. So let's say I wanted to pull another image. The syntax for this is, so first you need to know the username in Docker Hub, which in my case is Dan Shapero. Then the name of the image, which in this case is UWESS 524. And finally, there is something called the tag, which is like a version number for it. So you can see that I had one version that I uploaded on April 25th and another version that I uploaded on May 7th. So the tag for that is 2024-05-07. But depending on what repository or which image you're looking at, they may have a different naming scheme. It's literally just any string that they can put in there as a tag. So this is going to take a little while to fetch the thing. And
Dan, can you
I'm
drop that URL in the chat?
sorry. Oh, do you want a link to it?
Yeah,
Oh,
yeah,
or
it
command?
just because I'm too lazy to type that.
That's totally fine. Uh, oh, will it let me select it? Oh, and please feel free to interrupt me with questions. So yeah, as I mentioned, these are often kind of large, and you're probably going to want to find some way to contain the disk space usage at some point. And if that's a concern, then you should ask me about it later, and I can show you the right commands that will keep this under control. And I can also show you later at the end, I'm going to talk about how to create a Docker image, and I can show you how to upload them to Docker Hub. So just as an example, while this is fetching, um, if you go to, say Explorer, they have a lot of popular ones. So there's some that already have TensorFlow, PyTorch, some with large language models, and some that are like much more stripped down. So often people use these for they're running them asynchronously in some server somewhere. And so having a really minimal Linux installation is a priority. So Alpine is a popular one for that. And there's others that have, for example, Jupyter Hub already built onto them. So you can often just find useful stuff that's already prepared. As I mentioned, so this software package that I like using, they regularly create and upload their Docker images for people who have a hard time installing it natively, which is frustratingly frequent. And odds are your favorite software package, they probably already do that. Um, there's one in particular that have this uploaded here. No. Well, anyway, there's another one that is used a lot for remote sensing that is famously difficult to install. And I know they have some image prepared somewhere for it. Um, okay, we'll wait for this to finish and I can use a different image to illustrate the rest of this. Um, so, okay, so if I look at the images that I have, the next thing that I'm going to want to do is actually run one of these images. So the next command that's important is docker run. And there's some extra flags that we have to pass if we want to be able to do anything interesting. The first is interactive, and the second is teletype. And I think almost no one in this room is old enough to remember what a teletype machine is, least of all myself. But in the early days, we had to interact with computers via these giant god-awful machines that were separate from the computer itself. It was called a telex machine. Um, and the reason that we need these is that often people are using these sorts of tools to create a server that or create some other processing system that runs entirely in the background. And that's kind of the usual use case. So if we want to actually be able to run commands, we have to tell it that we want it to spin up a terminal for us in which we can type things. So once again, the syntax, if you remember from when we were pulling, we had to specify the username, the name of the image, and the tag. It's the same thing when we're specifying which image we want to run. So for example, I can show you here, if I do ls, the things that are in the home directory here is there's something called Firedrake. There's a log for when it was installing it, a giant software package called PETSI for scientific computation. And if I open up another terminal tab, I can show you what's in my home directory. It's not that. So this container has an isolated file system from that of my own host machine. So, this has this Python library already installed. So I can activate a virtual environment and import Firedrake. Whereas on my home machine, uh, I might not have anything installed. See, I get a no module named Firedrake here, but in the container I do. This is not a lecture about finite element analysis, so I won't actually go into much detail there. And so you can imagine doing a bunch of computing in here, and then when you're done, you hit exit like you would from a normal terminal session, and it drops you out of it. So if I were to start another container from that image, then there's no persistence. So if I start up a container, I do some computing and I exit it, and there were some files that I needed, then those files are gone the next time. So each one of these containers is totally fresh, and that is by design. And I'm going to show you what you need to know in order to actually persist things or to transfer stuff from one container to the other in just a moment. Um, Oh, another thing that is perhaps useful. Um, if you just fetch an image, and actually, so this Firedrake image has a lot of stuff built on top of it, but you also have super user privileges in this particular image. So, for example, if you have permission to use Docker on another server, but you don't have super user privileges on that server to install other software that you might need, then you do have super user privileges inside a Docker container, which can be pretty useful. So, in this case, I just installed Patch Elf because I knew that I needed that for something.
I use this a
Um,
bit. I used to have a Linux machine, but it died, and so I have a
uh,
Mac and I run Docker. If I want to do testing for Linux, I use a Docker container.
Oh yeah, so that's
Network
another
Linux.
great example is like you have software that you need to distribute, but you are not filthy rich, and so you only have one laptop. So you can try it on a bunch of different operating systems and make sure that it's going to install properly on all of them. So here I fetched another image, which is called build pack deps or build pack dependencies. So you can see that it's much smaller than all of the other ones. And this is popular for building uh, other larger images on top of. And what I want to illustrate here is um, the first image that I showed you is one that the Firedrake developers already prepared, and it has a user account and a lot of other software installed on it. But some images are much more like bare systems that have almost nothing at all. So if I start up a container from this image, I can see there's no user account. It just drops me into the directory slash. There's basically nothing there. Um, so, uh, like how much is already set up for you is going to depend on the image. And it's nice when someone already has done mostly all the work for you already, and you don't have to worry about that sort of thing. Okay, so I'm going to exit out of this. There's one more command I want to show you before we get to the rest, which is Docker PS, and it shows all of the running containers. And when I just did Docker PS, it showed there was nothing there. That's because I didn't have any containers running. But if I do Docker PS all, then it shows even containers that I've exited from. So I exited from that build pack deps container 24 seconds ago. I exited from the Firedrake vanilla one 9 seconds ago and another one 3 minutes ago. And these have names that are randomly generated, like condescending McClintock. And so there are cases where you might need to restart stopped container. And that unique name is something that you can copy and paste. Um, and so, for example, if you see you have a whole load of stopped containers, you can often delete them and save yourself some disk space. Okay, so the important things that by far the most important stuff for you to know in order to be able to use these effectively are how do I share files and how do I use a Jupyter notebook? So the first one I'm going to show you is how do I share files between my host system and the guest system. So file sharing between your host system and the virtual machine doesn't happen by default. And the reason for this is that people are running these containers in some server that's owned by Amazon or Microsoft. And it's really very important that those containers be isolated from the host system. Otherwise, I could, you know, I could break out of the container and steal a bunch of files from Jeff Bezos and try and hold him to ransom for them. Not that I encourage this behavior. So if we want to share files, then we need to pass another special argument. So I'm just going to show you the contents of a directory I have on my host system, um, which is in .cache/icepack. And this has a bunch of netcdf files that contain some remote sensing data. It has some GeoJSON files describing the outlines of a couple of glaciers. So what I want to do is spin up a Docker image that has this folder synced to the container. So as usual, interactive and teletype. And the next thing, and I'm going to put this on a separate line, is _volume. And what that does is it syncs a directory on your host system to a directory in the container. And the syntax for this is first is the directory on your host system, and then a colon and the directory on the container. And the really annoying part about this is that it has to be an absolute path. And it has to be an absolute path on both your host system and on the container. And in order to do that, I need to know what the username is within the container. So when I spun up that container earlier using the Firedrake image, I knew that the username was Firedrake. But for example, if I did something silly and I thought that the username was Daniel on the container, then it might create that directory, but the permissions get weird. So I need to know something about how that container is set up, or sorry, I should say how the image is set up before I actually am able to do this. And there's other things that can make this simpler. So for example, I could go back and change home/Daniel to an environment variable. Now, if I do ls and I see what's in the data directory, then when I'm looking at this from inside the container, I can see all these TIFF files and GeoJSON files and netcdf files. And for example, I could create a text file. And if I go back here, I can see this hello.md is inside the data directory, and I created that from inside the container. And now if I go back to my host system, I can see that hello.md is in here. So I'm able to move files from the virtual machine to the host machine. And likewise, if I create a new file here, I created this from my host system, and now I can see it in the container. So a typical use case would be if you had some expensive processing job that you needed to run, and you have all the software already created within a container. You could run all of that, save the results to whatever format you like, netcdf, TIFF, or GeoJSON, and then transfer that to your host system, where hopefully you're able to, say, do all the analysis or plotting that you need less expensively and without a lot of challenging to install software just on your host and not on the container. Does that all make sense? Any questions before I move on? Okay. Yeah, let me know if you think of anything. So that's really the biggest part, is just being able to transfer files between the host and the guest system. Okay. Now, the next thing, oh, sure. Oh, the question is this type of volume considered a bind mount? I don't think so. this is getting into details that I'd rather avoid, but there's two different ways to share files. And I think what I'm showing you is a volume mount and not a bind mount. And we can come back to this towards the end. I honestly I haven't had a use case to need a bind mount. I think it's more of an issue when you have weird file permission discrepancies between the host and the guest. But I think this is just a volume mount. Okay. So the next thing I want to show you is how do we, well, first of all, I'm going to show you something that is going to appear a little annoying. And so you can appreciate how annoying it is. And then I'll show you how to fix it. So first, this Docker image had Firedrake already installed in it, but it didn't have Jupyter or Jupyter Lab already installed. So I'm going to pip install all of that from within the container, and then I'm going to try and start up a Jupyter notebook. You can tell how many times I've had to do this because I actually remember the commands. So I installed Jupyter and I'm creating an IPy kernel for it. And now let's try Jupyter Lab. And I'm doing this within the container. Okay, so we're already seeing some things that are interesting. It says no web browser found. Could not locate runnable browser. Normally, if I start up a Jupyter notebook on my host machine, it's just going to fire up a web browser automatically. But within a container, it has no graphical user interface, so it is not able to do that. So the process is a little more manual, right? I have to go copy this URL from the terminal and paste it into the browser. And what do you know? It's not able to connect. So that's odd. Why isn't this working? A thing to notice here is, so it's annoying because you have to sort of actually understand how and why Jupyter works, which I never wanted to do, but here we are. So what it's doing is it's creating a web server on your machine, and you're connecting to that web server in the browser. But it has to do so over a certain port. And once again, because people are using these in the cloud, there are security considerations, and we can't just have every port on the host be visible within the container. So once again, there's another argument that we have to add when we start up. When we start up the container. So I'm going to add all of the arguments that we had before. And the new one that I want to add is called publish. And what this does is it says, take any port on the host machine, which in this case is 8888, and map it to another port on the virtual machine. And this is what we're going to need in order to use Jupyter. And the annoying part is, so I exited out of that container where I had already installed Jupyter and Jupyter Lab. And I realized that I didn't map the ports. So then I had to exit out of that container, map all the ports, and start up again with the ports properly mapped. But now when I start the new container, I don't have Jupyter. So that's annoying. I have to reinstall it again. There's a fix for this, and this is what I'm going to show you in the second half of the talk, is how to create your own Docker images that will have all of this taken care of for you. So I know this is a little silly to watch me do the exact same thing again, but I think there's some illustrative value there. Okay, so I'm going to start up Jupyter Lab again, but there are a couple of extra things that I need to do when I start Jupyter Lab. The first is to tell it to use the IP 0.0.0.0. so it doesn't do anything funny. I'm going to tell it to use port number 8888. And I'm going to tell it, don't bother trying to open a web browser because you don't have a graphical user interface. I think this is going to go. There's one more thing that I could have done, but we'll leave that aside. The other thing, the stuff that they do for security that usually you never notice is there's this big long token string. The reason that's there is if you were sitting running Jupyter in a cafe, you wouldn't want someone else who was on the same Wi-Fi in the cafe to be able to mine cryptocurrency off of your laptop. Okay, and now this time I was able to start up a Jupyter Lab server. Oops. And now I can actually do sort of interesting things. Well, that's curious. Of course, in a live demo, something has to break. So we'll ignore that and move right along because it doesn't particularly matter. Um, so uh, those are really the two biggest things that you need to know in order to be able to use this effectively is how to sync files and how to get Jupyter to start. And it's a little annoying that you need to remember all of this stuff. I have a markdown cheat sheet with all of it that I used to just keep pasted next to my screen. But I have the file that I can share that because I don't expect everyone is going to remember all of those commands. But that's really the two biggest parts. And this is all assuming that someone has already prepared a Docker image for you that has whatever weird unconventional software installed. Um, I'll take some time for questions, and then in the last part of the talk, we can move on to how to make your own Docker image. So for example, one of the things that I experienced here is that this Firedrake image didn't have Jupyter or Jupyter Lab already installed. And it would be pretty annoying if every time I wanted to go do some work, I would have to redo all of those commands. So what I'm going to show you next is how to avoid needing to do all of that, because someone might prepare an image that has, TensorFlow or whatever, or all of LandLab already installed for you, but there may be other things that you didn't know you need. So for example, like the people who developed this are all applied mathematicians, and they made a finite element modeling toolkit, but they don't know that I'm always going to need, NetCDF or raster IO or Xarray or whatever. And so of course I can go in and install those every time, but that's a bit of a pain. So how do I avoid needing to do that? And I will show you how to do that in just a moment. Are there any questions before I go on to the second part of all this?
Feel free to unmute your mics or ask in the chat. I hadn't had a use case before, Daniel, for doing a volume mount, so that was really cool to learn.
Oh, how did you solve this problem before when you needed to, or did you just not need to do that
I
sort of
didn't
thing?
need to do it. I mean, I just,
Yeah.
just for the workflows that I have, basically it's installing software so other people can use it. So this is like a downstream problem for me.
Okay, I see. Yeah, I mean, a helpful way that I find to understand that is back when I was, running things on my PhD advisor's giant machine in the basement of our research building. Um, I could log in remotely, but if I wanted to transfer files back and forth, there was a special command SCP or Secure Connect Protocol that would say, take a file that was on his server and move it to my laptop or vice versa. And so, you can move files back and forth, but there's a little special ceremony around it. With how you do that with Docker is different, but the purpose is the same. Instead, we're saying map this directory onto that other directory in the container. Maybe rsync is a better comparison, but I haven't used that as much. Okay, so the next part that I want to look at is how do we create a Docker image from one that already exists? So a helpful thing, I never really remember how to do any of this stuff. I mostly have just saved it somewhere that I figured out from some combination of Stack Overflow, and I go and refer to my own code before. So, okay, this is a pretty good one. So this is the Docker image that I used for the class that I taught. And I'm going to make a new directory. And so I'll basically recreate that so you can see how all of this works. Um, So there are only a handful of commands that you really need to know um, to do this effectively. So the first is from. And what this says is we're going to make a new Docker image and we're going to base it off of another Docker image. So once again, the syntax is the username and the image name and the version. So, oh, and I, of course, have a typo. And for example, this could be whatever you find off of Docker Hub or if your collaborators have already prepared one. And that isn't going to do much by itself. It just tells you what the starting point is of the image. The next useful thing is the command run. So, and this can basically be any shell command. So there's a Python virtual environment that I know is inside that image. And so I'm going to activate it and I could put all sorts of other stuff after there too. I could put in raster.io or Xarray or whatever else. Okay, I think that's going to be a pretty good starting point. So I mentioned before this sort of annoying problem that if someone has already created an image for you, but there's additional software that you need on top of it, then it would be kind of a pain if you had to reinstall it every single time. So what I'm going to do here is I'm going to make a new Docker image, and I could call it whatever I like, that has some extra software installed on it via pip. But crucially, this could be C code or Fortran code that needs to be compiled. And now I'm going to build that image. So I'm exiting out of my text editor. And this is kind of the next really big important command. So I showed you before, sorry, there's no dashes, the Docker run command. Now what I'm going to do is Docker build, and I have to specify a name for it. And the syntax, again, is the same as for when we call Docker pull or Docker run. There's the username, the image name, and then a tag, and I'm just going to tag it as a latest because I don't feel like making the version name. And finally, the directory where the Docker file lives. And I'll tell you why it's the directory and not the file itself in just a moment. So I think that's good. Oh, well, that's odd. Okay, of course, something has to go wrong. Oh, I messed up some syntax. I think it's important that people see that you make mistakes. Okay, maybe this is worth unpacking. What I'm doing is I'm chaining together a couple of commands here. First, I'm activating a virtual environment. Then I'm installing Jupyter, JupyterLab, and IPyKernel. And then I'm installing an IPyKernel for Firedrake, but I forgot the double ampersands. So it said there was a syntax error. So now let's try to build that again.
Hey, Daniel, a question.
Sure.
I've seen that style as well, and I think it's even recommended in Docker for chaining those commands together. But it seems like for debugging, that makes it more difficult because you weren't sure exactly which
Yes.
of the commands. Do you have any opinions on that at all?
Um, the answer is, do you do this or do you do that? And the answer is yes.
Okay, all right.
Um, well, okay. I try and keep logically, and actually, we can even unpack something that I did here that is different from what I just showed you. I'm going to come back to your question in just a second. Okay, if I do Docker images, I can see that I now have one that's called Dan Shapero / CSDMS webinar. And if I run this. Then inshallah it will work, which it did. And I'll be able to immediately start up a Jupyter Lab server, and I won't have had to reinstall everything again, which is pretty nice. That's probably some separate problem. Okay. Right. So almost everything that you could need is just contained in from and now, Mark's question was about whether you chain these together or whether you keep them separate. So for example, I can add another run command that might do something else. So here I could have it do, say, update and install patch elf, which I know I need for something else. So I often chain them together if they're logically related to each other. So for example, here I'm installing Jupyter and I'm making an IPy kernel for it. And here I'm, installing something from the package manager that is sort of unrelated. So I try and keep them all in a single run command if they're logically related to each other, and in separate commands if they aren't. Now, in principle, you could separate all of these into totally different run commands. It's partly a matter of choice. Now, one thing that is good to know is if I start building this image and one of the run commands fails, and it's because I made some silly, syntax error, like if I just forgot the F on the end, then if I ran this, it would fail when it, actually, why don't I even just show you that right now? I can talk about it or I can demonstrate. Okay, so it's going to update apt, and it's going to say that there's no package called patchL. But if I scroll up, it says run firedrake bin activate, install Jupyter Lab and whatnot. And it says using cache. So what that means is there was a previous invocation of Docker build that succeeded when I tried to install Jupyter. And so it doesn't need to redo everything that's in the entire Docker file. It will pick up from the last one that succeeded. And if now I go back and fix this, then it's going to work the second time around. But for example, like if I have one stage that is some really incredibly long installation of a giant C++ package that worked, and then something immediately after that that broke, then it's just going to pick up after the last one that worked. So it's not going to have to redo the hour-long compilation of, deal 2 or whatever other package it is you're looking for. Okay, the last one that really matters is being able to set environment variables. This is just an example. And I think that is the syntax. Yes, okay. So here, this is telling us that we want to make some environment variable that is equal to some value. And this is often important for there's many software packages that, and here we can see once again, so when I told it to install patch shelf, it's just using the cached value. And now it's set this environment variable to equal to 1. So if I do Docker run again, oh, aha. Oh, this is funny. So I forgot to exit from the other one, and I tried to use port number 8888, and it said, you can't run a container because that one has already been mapped. So I'm going to exit out of this one. I could also have used 8889 or 9000 or whatever you like. And so I can see that environment variable has been set in the container. The reason this is important is that there are some packages, I think I pulled up the Earth System Modeling Framework, for example. If you're compiling them from source, they require you to have certain environment variables set. Um, so it's useful to be able to set those from within the Docker file rather than have to do those separately every time you run it. There are a couple of others. There's a command copy, which is for copying files from your host system into the image, which can be useful because, for example, if I, like one use case that I might want to do that for is if I'm preparing a Docker image that is to run code that I needed to publish a paper, then I can bake a bunch of data files into the image itself so that all I need to do is start up a container and just hit a single shell script and it'll reproduce everything for the paper. That way I don't have to go through the --volume command every single time. So that can be a bit of a time saver. I can show you how that one works. There's others that if you're starting from a very, very bare bones image that doesn't have a user account set up, then you can create one and select the working directory. But those are a little, I see we're almost at 10 o'clock. So those are a little more, for later if you need them, but I think they're not the most essential compared to the stuff I already did show. So that's really, I'll go back to this Docker file here. Yeah, really just from run and env are pretty much all you need to do a lot of things. Okay, so Xiaofeng has asked, is it possible to create Docker containers across OS systems? So a Windows-based container running in Linux or Mac OS. So there are, you can certainly create a Linux image from Windows. And I think that you can create Windows images, but the issue is the licensing. Like you need a license key for it. This isn't something I've ever had to do. I think there's a pretty good chance that it's possible. If you want, I can look into that and follow up with you. But short answer, I don't know off the top of my head, but I think there actually is a good chance. You can now create Mac OS Docker images, and there are virtualization solutions for that. But yeah, there's extra steps to follow, but I believe it is doable.
For Mac OS, I learned recently if you do it for both, the ARM and the x86 processors.
Yeah, so that's another little thing people have had to deal with recently is because Mac has switched what processor architecture they're running. So they're using ARM chips now, but a lot of Docker images are prepared for Intel. So they have a translation or emulation layer that will run all the Intel code on ARM. So for the most part, you don't really need to see this over much. That was pretty much all of what I had prepared. I thought one more thing I could do. I know we're running up on time, but if people want to see it, I could show you a simple example of what if I wanted to add a compiled C library to this. Um, or if you have your favorite or your least favorite piece of software and you want to just work through this now, we've got some time. I can try and show you what would be necessary to install that into a Docker image. Up to you all. Thoughts, feelings, reactions. Also, if people need to go, that's cool too.
Daniel, can we thank you before you embark on a new thing here?
Oh, sure.
Thanks. That was really cool. I enjoyed your presentation. It was super cool. You did it interactively. I learned things. So thanks for doing this.
Yeah, thanks. Yeah, so there's uh a lot of stuff that like I presented this more as a nice way to get yourself out of a jam if you have to deal with really messy legacy code. But I also, there's a lot of stuff that it can be used really productively for. So for example, I use it for building my own personal website and for the documentation for a software package I develop. It's pretty handy for a lot of things. And there's also a lot of stuff that can make this smoother for you. I've shown that there are a lot of commands to remember. There's a lot of bureaucracy and boilerplate. So even just a simple thing of like, if you're regularly using the same image for a workflow that you run over and over again, then just wrapping up all the Docker run commands with publish and volume and whatever else into a shell script can save you a lot of time. There's a tool called Docker Compose, which would take me a whole long time to talk through, that will deal with persisting containers. So if you stop them, you can resume them later with all of the volumes already saved. That's pretty nice. I did all of my text editing here just with Vim because I'm a technological Luddite, but VS Code has very nice integration with Docker as well that lets you like not have to think about a lot of this stuff. So there's this thing can save you a lot of trouble. There's maybe some extra bureaucracy and boilerplate, but there are other tools that can also save you from having to deal with a lot of that boilerplate also. Oh, sure. Okay. So Danielle has asked if I could just walk through some of the commands again, just to kind of cap all this off. Um, so the most important one is, so Docker images shows you which images you have. Docker pull will fetch a new one. Oh, and I mentioned some of the caching features before. So for example, if oh, okay. Well, it would be good to just review all of this really quickly anyway. So Docker pull will fetch a new image, and Docker run with interactive and teletype is the thing that you need to run a container, which I'll just do really quickly now. And that's pretty much it for what you need to do in order to be able to run them. And the next part is if you need to build things. For the most part, almost everything you need to do is just picking a good image to build off of. And there's ones that already have SciPy and other stuff already on them, and the run command that you can use to install additional software. So I showed some that were just installing Python packages, but if people do want to stick around, I can show installing a C package as well. So I know this felt like a lot, but ultimately when you distill it all down, there's really only a couple of things that you actually need to be able to do with it.
If you
Cool.
have your little markdown file with your cheat sheet
Oh yeah.
and that would
Why
be
don't
cool to share for
why
sure.
don't I send that around? I could put that in the chat or elsewhere. Um, so this is all contained in a README file I have from the repository for a course I taught in the spring. So here I have, this is describing the volume command, port mapping for Jupyter, and that was pretty much it. So I'll just put that in the chat right now. Yeah, and I've had to like, I know it looked like I remembered most of this time, but I have to refer to my own notes like so many times because I just forget all this stuff all the time. Cool. All right. Thanks everyone for coming. Um, I figure if we've got some extra time, I can just show you what it looks like to do something like install Triangle. If you are a Triangle mesh enjoyer. So the first thing that I have here is I have a command to fetch a zip file containing this source code for this mesh generator. And partly some of this I have to figure out by going back and forth between my own system and the Docker file. So a lot of this involves like a bit of multitasking. So I think this will work. So roughly to sum it up, I'm fetching a zip file containing the program I want, making a new directory for it, moving the zip file into that directory, changing to that directory, unzipping it, and running make. And let's see if this is actually going to work. I'm going to be a little amazed if this works on the first try. Okay, so it didn't have wget. That is the thing that we can fix. So here what I did is I went back one command. I was installing patch elf, figuring that I might need it. And now I'll add wget to that as well. I could have also replaced this with curl because I think the Docker image already has curl on it. So let's see if this will go. It's going to have to fetch some stuff again. So I realize this is like a little messy what I'm doing here. I want you to see the mess because often doing this sort of thing. Okay, so it didn't have unzip. Requires a lot of Googling. Okay. Sorry, I was doing that a little fast. So there is another program that I had to install. I have to go back, and in this sudo apt-get install command, I have to add unzip in addition to wget and all of those. And let's see if it gets a little further this time. Yeah. So I want you to see how messy this is when I'm actually doing this for real and I'm put on the spot. Because, like, if you see me give a very polished presentation, it might give you an unrealistic expectation of what it looks like when you're actually doing this for yourself. When you're doing it for yourself, it's always really, really messy. So behold the mess. So now let's go back and now hopefully when we go in here, we can see that I've installed this mesh generator triangle, this big old piece of 3,000 lines of C code all crammed into one file that has not been edited since 2004 and still works better than all the alternatives. So I'm able to just call the help file in there. And that's all that I really wanted to show for the rest of this is what it looks like to add compiled C code as well. And for example, if you were using something that needed CMake to compile, you can also install that using apt-get and so forth. Okay, really done.
Awesome. Thank you very
Thanks
much,
everyone for
Daniel.
convening. Cool.
Any questions? All right. Well, thank you very much, Daniel. It was very cool. Again, I learned something and I appreciate it.
Cool. Thanks. Yeah, I know it's not you know, the most exciting thing in the entire world, but boy, has it saved me a lot of heartache on many occasions.
Yeah.
So
Yeah, right on. Yeah, you mentioned like old models, and actually, I have had to try to install old Fortran models, and this is where
oh
you.
yeah, I bet.
Yeah.
Yeah, I got a lot better at this when I very foolishly agreed to try and couple an ice sheet model to an ocean model. And the ocean model was some old Fortran code. And having these kinds of tools was it just would have been totally impossible otherwise. It just saved us so much time.
Believe it.
Yeah, cool.
Okay, all right. Well,
Great.
thanks everyone. We'll see
Thanks.
ya.